So I'm looking at example 1 on the notes packet. And, oops. Okay, so what I do when I'm going to solve is I will first label the sides, O, A, H, and then secondly, I'm going to choose whether I should be using sine, cosine, or tangent, based on what sides are involved in that question. And then I'm just going to set it up and solve. So, alrighty then. In this problem, the x is across from the 55, so that'll be my opposite side. And the 42 is across from the 90, so that's my hypotenuse. This side over here, they're not asking about it, and they're not telling me anything about it. So I don't care what it is, even though it's adjacent. So because I've got opposite and hypotenuse involved in my problem, I'm going to choose sine. Now, in geometry, we always set it up as cross product. You guys might not need to do that, but I would write the sine of 55 over 1 equals, and then on this side, I have to put opposite over hypotenuse. So the opposite is the x, the hypotenuse is the 42. So we set it up like that in geometry so that it's always cross multiplying. If you don't need this part and you're fine with solving it that way, that's fine too. What would I have to do to solve for that x? It's currently divided by a 42, so I would multiply that 42 up to this side. And now on your calculator, make sure that you're in degree mode. So go to mode right next to the yellow second button and just check that you're in degree mode. Otherwise, everything will come up kind of funky. And then I'm just going to type in 42 sine 55 and find that the side is 34.4, and it asked me to solve the nearest tenth, so I'm going to go ahead and do that. Do you guys remember doing this in geometry? Are you guys like not speaking to me or what? Okay. So everybody has total understanding then, and move on. Keep in mind, you are also not captive. If you are like, okay, I get it, peace out, you can always leave the meeting. And then if you need help later, you can go back and watch that part of the video. So here, in the second example, I have a 63-degree angle, a 90-degree angle, a 13, and the x is over here. So I'm going to go through that same process. Across is this, so that's my opposite. The hypotenuse isn't asked about and it's not labeled, so I don't need it. This guy right here, which is next to my angle, is my adjacent side. So always refer to so Toa, which one are you going to use? Okay, nobody said it. Tangent. So the tangent, if you want to put it over 1 to set it up as cross multiplying, you definitely can. But the tangent of 63 is going to be my opposite, which is 13, over my adjacent, which is x. So this one's a little trickier because the x is on the bottom, but not really. If you followed through with cross multiplying, you would end up with x times tan 63 equals 1 times 13. And then to solve for the x, you'd have to divide that tan 63 to the bottom. What I usually do is I don't set it up like this once I'm in algebra, and I just realize that if the x is in the bottom, I'm basically going to flip-flop those. So to solve this one, rather than multiplying like we did, I'll take 13 and divide it by the tangent of 63. So I'm ending up with a value over here of 6.6, which makes sense. I mean, it's in the ballpark of my 13. All right. So in number 3, they're trying to confusify you by setting it up kind of weird. But we're not going to fall for that. Looks like 40, looks like this is 57 degrees. And then it looks like we're looking for this guy. So across from 90 makes this my hypotenuse. The opposite side would be over here, but there's nothing there. They're not asking me about it. I'm not told what it is. So that makes this guy the adjacent. So with adjacent and hypotenuse involved, I'm looking at using cosine to set this up. I'm tripping on the dog wall. So the cosine of 57 is going to equal my adjacent, which is the 40, over my hypotenuse, which is the unknown. And again, there's really only two things that can happen. The x ends up on the top or on the bottom. And in this case, it's on the bottom. So I'm going to flip-flop these two, and x will equal whatever 40 divided by cosine 57 is. Now, when you go to IXL, and if you want, before we leave this Zoom, I'll help you make sure you find the ones we're working on. It's like super simple. The first one is just going to say, hey, what is the cosine? So you would go, you know, whatever this number is over that one. The second one just has you type stuff into your calculator. And then, okay, Steve, I just saw you, which reminded me of the picture you sent last night, which was so funny.
Oh, yeah.
Okay. So the 3 IXLs that you have to do are very basic. It's not even till the third one that you have to do what I'm doing now. All right, so 40 divided by the cosine of 57 is 73.4. So is that logical? Like over here, I've been getting like 6, 5. Well, yeah, because this one has a length of 40, and the hypotenuse has to be larger than that because it's the hypotenuse, and that's part of its job. Is this so easy? Are we good?
Yeah.
Okay. So do I need to do this fourth example, or can I jump to the word problems?
Jump to the word problem.
I'm going to jump to the word problems. I was hoping you would say that. I wonder if my dogs are going to be really smart and know a lot of math by the time this is all over. What do you think, guys?
Probably.
Probably not, because look, they're not
Probably not.
They're just sleeping on the couch. Losers. Actually, that's probably where the other half of our class is, too. Alrighty. So, okay, the word problems aren't even challenging. What is every single word problem going to turn into as a picture? A right triangle, and then you're going to do the exact same thing. So it'll get fun later when we do non-right triangles, but right now it's just going to be straight up triangles. Right triangle. So you lean a 16-foot ladder against a wall. We're going to assume the wall is vertical. We're going to have our ladder leaning here, which is 16 feet. And then it says, if the ladder makes an angle of 70 degrees with the ground. Ooh, let's talk about that. There is one thing that you need to know. It's called angle of elevation. So sneak peek, that's going to be on your quizzes on Friday. You want to know what angle of elevation means. And, you know, I'm not going to be at your house, so you can't come up and ask me questions during the quiz. Angle of elevation kind of is what it sounds like. If you elevate, you lift something up. So whenever they talk about the angle of elevation, so in this case, from here up. So this has an angle of elevation of 70. Whatever the horizon is, 70 degrees higher than that. So just know that term. Okay, and then it's asking how tall is the, no, it says how high does the ladder reach? So this is actually the thing they're asking about. It's not asking how far away from the wall is the ladder, it's asking how high does it go up. So just like all the other problems that I was making you watch me do, here I'm going to say, okay, well, the wall is straight across from and therefore opposite from my angle, and this is across from the 90, so that makes this my hypotenuse. So because these two guys are involved, I'm going to set this up using sine. So the sine of 70 will be my opposite, which is unknown, over the hypotenuse, which is 16. And this is the one where to get x alone, I simply multiply that 16 up. So what I'll be entering into my calculator is 16 times the sine of 70 degrees. And anyone who joined in a little bit later, just make sure that your calculator is in degree mode. And so this is telling me that this building is 15.0 feet. And that is, the reason I wrote it funny like that is my instructions say round to the nearest tenth. And it's actually 15.03 calculator, which would round to 15.0. So I'm going to just go ahead and do that. And that, my friends, is all we have to learn today, because apparently we are taking it really slowly in case anyone's stressed out about getting their online stuff. So now let's use the little raise your hand feature. And if you can't find it, what you do is you go to the bottom where it says participant. When you do that, you're gonna be able to see over on the right, and you'll be able to, how do you put it in degree mode? Okay, awesome question from the crowd. By the way, I turned off the private chats because a lot of you that inappropriately, probably not a lot of you that are on here now, but we don't want our moms knowing we chat that way behind the teacher's back, so I just shut that down. So on your calculator, you would go to mode, which is right next to the yellow button. And then third thing down, how can you do this? Third thing down gives you the choice between radians and degrees. And we do get the thrill of learning all about radians and getting prepared for pre-calc, but right now we're doing degrees. So I make sure I'm in degree mode, and then I can go back and do my thing. So under participants, if you hit that, on the right of your screen, you're gonna see a list of who's in the room. And then you can raise your hand. Down at the bottom, I think it says raise your hand. So if you want to raise your hand to ask a question, you can do that. I'm not muting you guys, so if you want to ask me a question, you can certainly do that. But just know how to do that. I think I talked about it yesterday, not everybody found it. So find your participants list, and then at the bottom, you should have the option to ask a question or raise your hand. Okay, I feel like everyone's probably good on the material. I do want to just show you how to find what you're supposed to do for IXL. So does anybody have those handy? I wrote them down, but I can't read my writing on this one. So here we go. I'm going to end this recording because nobody cares about this part.